Guys. Okay, if I can get into this. So basically, when you add or subtract algebraic fractions, it's exactly the same as normal fractions. And the thing about normal fractions is you have to have the same denominator. Okay, the denominator has to be the same when you're adding or subtracting fractions. It's not the case when you have multiplication. We'll look at that tomorrow. But when you're adding and subtracting fractions, the denominator has to be the same for you to be able to combine them into one. Okay, and then the same rules then apply for pronumerals, for variables. So if they're like terms, if it's the same variable to the same power, then you can add them together and simplify the expression. But if they're not like terms, you can't simplify. Alright, so we'll have a look at some examples. But it's basically the same. Don't think of it as any different. It's the same as normal fractions and numerical fractions, and it's the same as all the other algebra things we've done in terms of collecting like terms and simplifying. Okay? So, sorry? It is. Good. Alright, so the first one. I was playing around with it, that's right. Here we are. Okay, so if we have a look, we've got 4x over 5 minus 2x over 5. Now the denominators are the same, which means we can combine them into one fraction. Alright, you can combine it. So I can write it like this. 4x minus 2x over 5. Alright, and as Giles already said, 4x and 2x are like terms because x is the same. And so 4x minus 2x is what, Giles? 2x. So it's just 2x over 5. Okay, so in this case we didn't have to do anything. The denominator was already the same. We didn't have to change it or multiply it by anything. It was simply the same denominator. Now, the next one, Nick. Are the denominators the same? Yes, they are. Okay? They're the same. Right, so we can combine these into one fraction because we don't have to worry about the denominator. We just know that they're the same. So P and 4, are they like terms? No, they're not like terms. It's just P minus 4. We can only write it P minus 4, and you can't simplify it anymore because P and 4 are not like terms. So that's how you leave this. You just combine it into one fraction, P minus 4 over 3. And that's it there. Okay? So it's simply that if the denominator is the same, combine it into one fraction. If the numerator can be simplified, you simplify it. If not, you just leave it as an expression. So in this case, P minus 4. We just leave it. Right. Now this one here, 5y over 3 plus y over 5. Oh, so the denominator is the same. No. So what do we have to do? Tell me what you have to do. Good. So find the common denominator. Alright, so that's what we've got to do. Find the common. Yeah. Alright, just listening up. Find the common denominator. The easiest way to do that is to multiply the two denominators together. So we do 3 times 5 equals 15. So that's what we're going to be. That's what's going to be our common denominator. So let me write the next step like this. So we've got 5y over 3. Now how do I go from 3 to 15? What do I have to multiply by? I have to times it by 5. So I'm going to do times by 5. But I don't want to change the value of this fraction. I want to keep it the same value. I just want to write it differently. So if I times the bottom by 5, what do I need to do with the top? Yeah. Times by 5 is right. Alright, because we want it, whatever you do to the bottom, we're changing to equivalent fraction. Whatever you do to the bottom, you have to do the same to the top. So 5y times 5 as well. Now, I'll go to the next one. How do I go from 5 to 15? How do I times by 3? So I'm going to multiply the bottom by 3 to make it into the denominator of 15. What do I have to do to the top then, which is y? I have to also do the same. I multiply it by 3. Alright? So multiply it by 3. Now, I'll just move it up. So that, yeah, so then I can simplify these expressions. So 5y times 5 is, what is it, Charles? 25y. Okay, over 15 plus 3y over 15. Now we have the denominators the same. So look, what is 25y plus 3y? Okay, we can combine the fractions. 25y plus 3y is 28y. 28y over 15. Yeah, so that's a longer process. But can I say this again? Often students, that you don't want to take the time to take these steps. So what I do in examples is I'm trying to model for you how you should maybe think it through. Some of you are going to just be able to go from here to here and then straight to the end and get it quickly because you understand what you're doing. Others, maybe it takes a bit longer, and that's fine because we all learn at different rates, different speeds. So can I suggest to you that you actually take these steps? Think about what the common denominator is, if they're different. Then write it out like this, where you multiply the top and bottom with the same thing, and then take each step as you go to get to the solution. Okay, much rather do that and take your time so that you can understand it and follow the process through. Okay, and then by doing that, you're actually understanding what you're doing and following it through carefully. That's right. All right. Next one. 8x over 3 plus 3x over 4. Alright, so the denominator is the same. Now, what's the common denominator going to be? The common denominator, what do you think it should be? 12. How do you get 12? Yeah, he times them together. So common denominator of 12. Let's put that brackets here. Common denominator is 3 times 4 equals 12. Alright? And we do that because the denominators are different, Nick. So we'll write it out like this. 8x over 3. Now to get to 12, you have to multiply 3 by 4. And then so we have to do the same to the top. Right? How do I go from 4 to 12? What do I have to do before to get to 12? Times by 3. So I've got 3x over 4 times 3, and I'm going to multiply the top by 3 as well. 8x times 4. What's 8x times 4? 32x over 12 plus 3x times 3. Mitchell, what's 3x times 3? 9x. Good. So we've got 9x over 12. And Caitlin, what's the final thing going to be? Good. 41x over 12. Alright? So you just leave like that. Can't do anything else with it. Okay, can't do anything else to it. It's simply 41x over 12. Okay? So again, you're taking the steps. If you want to skip some of them because you're familiar, that's fine. But follow through the steps. Having strategies to approach these questions is really important. You don't want to get into a situation you're sitting there thinking, I don't know how to do it. But if you know that, okay, I have to do this first, identify things, that's a useful thing to know. Final example. X over 3 minus y over 8. Frankie, what's the common denominator here? How's it 21? How's it 21? Yeah, so what's 3 times 8? You said your method is right, you've just done it wrong, that's fine. What's 3 times 8? 24, that's right. Is that it? That's alright, don't worry about it. Common denominators is 3 times 8, which is equal to 24. Alright, so again, I'll write it out. So x over 3, I'll extend that. We have to multiply the bottom by 8 to get to 24. We have to multiply the x by 8. Then we've got y over 8. To get from 8 to 24, we have to multiply by 3. Okay, so 8 times 3, and then you have to do the same to the top. So what you get is 8x over 24 minus 3y over 24. Now we combine these into one fraction over 24. What's in the numerator? What's going to be the numerator here? No, is x and are they like terms? No, they're not like terms. So can we simplify it all?
8x minus 3y over 24.
That's it. 8x minus 3y over 24. That's all you can do. You can't simplify it anymore. You simply write it as the expression with the unlike terms, with the x and the y. Alright? So that's basically what you need to do. Thinking about changing the denominator if you need to, combining the fractions, and then simplifying if you can. Alright? So exercise 208.